It's been some time since 10 gigabit USB standard SuperSpeed Plus was introduced, yet there are still many people buying old generation USB storage devices today. It's mostly because they are unaware of current possibilities on the market and they do not know about the speed differences between different USB standards. That's why I put together this chart, which will show you all current USB standards and their speeds in one place. All boxes in today's video will be using USB 3.1 Gen 2 interface, which has a theoretical limit of 10 gigabits or 1.25 gigabytes per second. It has the same speed as USB 3.2 Gen 2 and they are both compatible, so it doesn't matter if your laptop or desktop has any of them. If you have a higher version of USB-C port on your PC, it isn't a problem as well, because they are backwards compatible. Anyway, I think it's time to leave the past behind and move forward. So we'll have a look at two external boxes which can be fitted with M.2 NVMe SSDs and one which can be fitted with SATA SSD. Personally, I like having the ability to influence the performance of IT infrastructure I own. That's why I chose empty external boxes and not the ones which have drives inside them already. This gives you the flexibility to pick whichever brand of drive you like and buy it at the best price you're able to get. Because the drives aren't hardwired to these boxes, you can exchange them at any time or put them back inside your PC if that's what you want to. Now I'll unpack all the boxes and assemble them. Then I'll run some benchmarks to find out what speed can be achieved using them. And then I'll talk about the whole experience and give you some tips before you make a decision whether you like them or not. So, let's get to it. This is what you'll find in the box: a quick installation guide, an aluminum box for M.2 SSD, 3 thermally conductive pads, small Phillips head screwdriver, 2 standoffs and 4 screws for mounting the SSD to the box. What you'll find in the box is this quick installation guide, a textile sack, metal heatsink, silicon thermal pad, the SSD box itself, the IB-1817M-C31, a Velcro strap, small Phillips head screwdriver, and 2 standoffs and 5 screws, then a front panel for closing the SSD box from this side, and a special tool for accessing the write protection switch on the SSD box, and 2 USB cables, one with 2 Type-C connectors and one with 1 Type-C connector and 1 Type-A connector. Let's check the length of the cables. As you can see, the write protection is off. If I wanted to turn the write protection on, I would take this tool and move this bar, and now the write protection is on. So I'll switch it off. Inside the package, you will find this USB-C cable, a user's guide, Phillips head screwdriver, the box itself, MySafe USB-C SATA External Case, 4 rubber legs, and 8 mounting screws. Let's check the length of the cable. Now that the boxes are assembled, we can put them side by side and check out the size differences. The largest one is the i-tec, which is 12.5 centimeters long. Axagon in the middle is exactly 1 centimeter shorter, which means that it's 11.5 centimeters long. And the shortest one of the three is ICYBOX, measuring 10.3 centimeters. All boxes will fit into a common laptop bag easily. When it comes to weight, there are significant differences between them. Axagon is the lightest, weighing just 44 grams without an SSD. ICYBOX weighs exactly 100 grams, which makes it more than twice as heavy. i-tec adds another 50 grams, which makes it the heaviest out of the bunch, weighing 150 grams. Out of curiosity, I also weighted all boxes with SSDs and with cables so that you know how much weight you'll be carrying with you when you travel. So let's have a look at the temperatures. I measured the temperature while all boxes were connected to the USB-C 3.1 Gen 2 port on the motherboard, while the computer wasn't loaded at all. The differences between the boxes are significant. i-tec using a SATA drive was the coolest in all time intervals, reaching only 38.2 degrees Celsius after 2 hours of operation. ICYBOX using an M.2 drive was much warmer, reaching 45.7 degrees Celsius, which is 7.5 degrees Celsius more than i-tec, but this behavior was expected. Because generally all M.2 NVMe drives run much hotter than SATA drives. Axagon was the hottest of the three, adding another 7.5 degrees Celsius after 2 hours of operation, reaching 52.2 degrees Celsius. It was a little uncomfortable to hold at this temperature, so it's best to leave it resting for a minute after disconnecting. This behavior has probably a lot to do with its weight, being the lightest one. Its aluminum cover is having difficulty dissipating the amount of heat generated by M.2 SSD. Now it's time for the performance benchmarks. Each of the USB-C external boxes was tested with 2 synthetic benchmarks and 8 real-life benchmarks consisting of 4 write speed tests and 4 read speed tests. The real-life benchmarks will show you what speed you can expect when using the boxes in daily use. I'll show you the whole run of each test so that you not only see the speed but also its consistency throughout the whole test. Before we begin with the benchmarks, there are a couple of things that need to be addressed. To simulate a real-life scenario during all copy tests, all external boxes were connected to the USB-C port on backplate of the motherboard by their original cables. When I ran synthetic benchmarks, ATTO and CrystalDiskMark, I had to connect both M.2 boxes to the standalone USB-C PCI Express card, otherwise the benchmarks would freeze and the application would become non-responsive. It might have been caused by imperfect compatibility of the M.2 boxes with the USB-C controller chip on the motherboard, or some other issue I'm not aware of. If you know the cause of this behavior or have the solution, please let me know in the comments below the video. It repeatedly overwhelmed the controller and it stopped working and the computer had to be restarted. Anyway, when it came to real-life use, all copy tests ran without any problems while all boxes were connected to the USB-C 3.1 Gen 2 port on the motherboard. So let's start with synthetic benchmarks. Remember that you can pause the video at any time. The first in line is Axagon EEM2-UG2 in CrystalDiskMark. The results show us that the peak read speed achievable with this box is around 1088 megabytes per second and a write speed of 1096 megabytes per second. Remember that these speeds can be achieved only for a limited amount of time, and real-life copy tests will show us the numbers which are significantly lower. This test was intense and heated the disk by 12 degrees Celsius, while the ambient temperature was 27.5 degrees Celsius. Now let's move to ATTO disk benchmark. This benchmark shows us that both reading and writing of files which are 128 kilobytes and larger will run at full speed of the disk, which will be limited by the maximum achievable speed of this M.2 box, which is around 1 gigabyte per second. As in the previous test, this applies only for short periods of time. Now it's time for 4 real-life write speed tests, which are designed to find out what you can expect in the daily use. The first one is 9.2 GB compressed single file copy test. It will run in real time. The write speed was consistent during the whole run of the test, reaching steady 560 megabytes per second, which is okay, I guess, and is definitely better than what even the best SATA external drive can offer. Yet, it is far from the expectations set by synthetic benchmarks, and that's the reason why I do these extra tests. The temperature of the drive during the duration of the test has risen by 3 degrees Celsius. Now, let's look at 20 GB uncompressed single file copy test. The write speed sits during the whole time at 560 megabytes per second, which is the same result as the previous test. As we can see, the compression of the file has no effect on the speed, which is a good thing. The temperature has risen by 4 degrees Celsius. Let's move to the multi-file write speed test. It consists of 8,000 small compressed files, which take 10 gigabytes of space. As you can see, the speed is fluctuating during the whole test, depending on what sizes of the files are being written. Anyway, having the ability to move 8,000 files of this size in 35 seconds is a fine result and shows us that this drive is usable even for photographers on the go who need to offload images from their laptops and don't want to age while doing that. The average speed was around 260 megabytes per second, and the temperature has grown by only 2 degrees Celsius. Now, let's have a look at the most intense test, the 100 GB compressed file copy test. The time is sped up 10 times. The write speed was very consistent, hanging around 560 megabytes per second. There is a small dip in performance in the middle, but it's absolutely insignificant. 100 gigabytes in 3 minutes and 6 seconds is a very nice result, and it clearly shows the advantage over SATA SSDs. The temperature of the drive has risen by 10 degrees Celsius. Now let's have a look at the read speed tests of Axagon EEM2-U.G2. The same files which were written to the drive in previous tests will now be read from it. The first in line is 9.2 GB single file read speed test. It will run in real time. The read speed was consistent, hanging around 810 megabytes per second, which allowed the file to be transferred in 10 seconds. This is nice, and it clearly shows the advantage of using M.2 NVMe drives compared to old SATA drives. Now, let's have a look at 20 GB uncompressed single file read speed test. The speed achieved during this test is even a little bit higher compared to the previous one. It's sitting around 830 megabytes per second and allows the 20 GB file to be transferred in 23 seconds. The temperature has risen by 3 degrees Celsius. Looking good so far. Let's move to the multi-file read speed test consisting of 8,000 small compressed files which take 10 gigabytes of space. Read operations are usually faster than the write operations. The whole file transfer took just 22 seconds, which is 13 seconds faster than the write speed test, so no surprises there. The transfer speed was over 400 megabytes per second most of the time, and the temperature has risen by only 2 degrees Celsius. The last test for Axagon is 100 GB read speed test. Most of the time the transfer speed was over 800 megabytes per second, and it dropped down after 86% of the file transfer to 1.3 megabytes per second for 15 seconds, and then climbed back to 800. This dip was probably caused by the inability of the destination drive, MP600, to write the data fast enough because its cache was depleted and it needed to take a breath for a few seconds before continuing to write again. The file transfer took 2 minutes and 24 seconds, which is a nice time for transferring 100 gigabytes, and the temperature has risen by 7 degrees Celsius. Overall, a solid result. Now let's move to the competitor, ICYBOX IB-1817M-C31. We'll begin with synthetic benchmarks. First in line is CrystalDiskMark. The results show us that the peak read speed achievable with this box is around 1088 megabytes per second and a write speed of 1095, which is exactly the same as Axagon. They are probably both using the same controller chip. Please remember that these speeds can be achieved only for a limited amount of time, and only real-life copy tests will show us real-life numbers. This test was intense and heated the disk by 10 degrees Celsius, while the ambient temperature was 27 degrees Celsius. Let's move to ATTO disk benchmark. This benchmark shows us that both reading and writing operations of files which are 128 kilobytes and larger will run at full speed of the disk, which will be limited by the maximum achievable speed of this M.2 box, which is around 1 gigabyte per second. As in previous test, this applies only for short periods of time. You can pause the video to check different speeds achieved with different file sizes. Now it's time for 4 real-life write speed tests, which were designed to find out what you can expect in daily use. The first one is 9.2 GB compressed single file copy test. It will run in real time. The write speed was consistent during the whole run, achieving around 560 megabytes per second, which is almost the same as Axagon. Yet it is far from the expectation set by synthetic benchmarks and what is claimed on the box by the manufacturer. This is the reason why I do these extra tests. The temperature of the drive has risen by 2 degrees Celsius. Now let's look at 20 GB uncompressed single file copy test. The write speed was holding around 550 megabytes per second, which is similar to the result which was achieved during the previous test. The absence of compression of file has no effect on the speed. The temperature during the test has risen by 3 degrees Celsius. Let's move to the multi-file write speed test. It consists of 8,000 small compressed files which take 10 gigabytes of space. As you can see, the speed is fluctuating during the whole test, depending on what sizes of files are being written. The ability to move 8,000 small files in 35 seconds is a fine result, and shows us that this use case scenario is usable. The result is exactly the same as Axagon. The average write speed was around 290 megabytes per second, and the temperature has grown only by 3 degrees Celsius. Now it's time for the most intense test, the 100 GB compressed file copy test. The time is sped up 10 times. The write speed was very consistent, hanging around 560 megabytes per second. There are 2 small dips of performance in the middle, but they are absolutely insignificant. 100 gigabytes written in 3 minutes and 5 seconds is a nice result and clearly shows the advantage over SATA SSDs. the temperature of the drive has risen by 10 degrees Celsius, which is the same as with Axagon. Now let's have a look at the read speed tests of ICYBOX IB-1817M-C31. The same files which were written to the drive in previous test will be now read from it. The first in line is 9.2 GB single file read speed test. It will run in real time. The speed was consistent, hanging around 850 MB per second, which allowed the files to be transferred in 10 seconds. It's a good result, which shows the advantage of using M.2 NVMe drives, because this speed could never be achieved with SATA drives. Now let's have a look at 20 GB uncompressed single file read speed test. The speed achieved during this test was very similar to the previous test. It's sitting between 830 and 850 MB per second and allowed the 20 GB file to be transferred in 22 seconds, which is exactly the same as with Axagon. The temperature has risen by 3 degrees Celsius. Overall, a solid result. Let's move to the multi-file read speed test consisting of 8000 small compressed files, which take 10 GB of space. Compared to write operations, reading should be faster. The file transfer took just 22 seconds, which is 13 seconds faster than write test, and exactly the same time as Axagon. The transfer speed was over 400 MB per second most of the time, and the temperature has risen only by 1 degree Celsius. The last test for ICYBOX is the 100 GB read speed test. Most of the time the transfer speed was over 800 MB per second, and it dropped down after 62% of the file transfer to 8.7 MB per second for a duration of 50 seconds, and then climbed back to 800 MB per second. This dip was probably caused by the inability of the destination drive, MP600, to write the data fast enough because its cache was depleted and it needed to take a breath to write the data from the cache before continuing to write again. The file transfer took 2 minutes and 57 seconds, and the temperature has risen by 6 degrees Celsius. Now let's have a look at the only SATA box in test, i-tec MySafe USB-C SATA External Case. We'll begin with synthetic benchmarks, first with CrystalDiskMark. The results show us that the peak read speed achievable with this box is around 504 MB per second, and the write speed of 506 MB per second. Hardware info recorded the peak numbers of 530 MB and 509 MB per second write speed. These are very good results for SATA drive, and they are showing that the USB-C 3.1 Gen 2 interface isn't limiting the drive's performance, as often happens when connected to Gen 1 boxes. Remember that speeds achieved in synthetic benchmarks represent only the capability of the USB box to perform this way for a limited amount of time, and only real-life copy tests will show us the numbers which represent everyday reality. This test was intense and heated the disk by 7 degrees Celsius, while the ambient temperature was 27.5 degrees Celsius. Let's move to ATTO disk benchmark. This benchmark shows us that both reading and writing of files, which are 128 kilobytes and larger, will run close to 480 megabytes per second for read operations and 450 megabytes for write operations. As in previous tests, this applies only for short periods of time. Pause the video if you want to check different speeds achieved with different file sizes. Now it's time for 4 real-life write speed tests, which were designed to find out what you can expect in daily use. The first one is 9.2 GB compressed single file copy test. The write speed was consistent during the whole run of the test, staying around 370-380 megabytes per second, which is roughly 32% slower than what was achieved with M.2 external boxes in this test. We are not comparing apples to apples here, of course. M.2 boxes were using Samsung 970 Pro drive. The reason I did it was to show the speed difference using SATA and NVMe drives in external USB boxes connected to PC by the same interface. What is worth mentioning is the real transfer speed, which is far from the expectations set by the synthetic benchmarks, which showed the speeds close to 500 megabytes per second, but for SATA external drive this is a good result. The temperature of the drive has risen by 8 degrees Celsius during the duration of this test, while the ambient temperature was 27.5 degrees Celsius. Now let's have a look at 20 GB uncompressed single file copy test. The write speed during this test was holding in a range of 360 and 370 megabytes per second, which is similar to the previous test. The absence of compression of the file had no effect on the transfer speed. The temperature has risen by 7 degrees Celsius. Let's move to the multi-file write speed test. It consists of 8,000 small compressed files which take 10 GB of space. As you can see, the speed is fluctuating during the whole test depending on what sizes of files are being read. The ability to move 8,000 small files in 33 seconds is a fine result, but it's 7 seconds slower than what was achieved with M.2 drives in the same test. The average write speed was around 246 megabytes per second, and with M.2 drives it was 290 megabytes per second. This is caused by the difference in the ability of different drives used and is in either case caused by the limitation of the bus or the interface. The temperature has grown only by 7 degrees Celsius. Now it's time for the most intense test, the 100 GB compressed file copy test. The write speed was on average around 350 megabytes per second, which is 47% slower than both M.2 drives. After reaching 35% of the file transfer, the MX500 starts to lose performance, probably because the cache is depleted, but it hangs in well till the end with only minor dips in performance. 100 GB written in 5 minutes and 3 seconds is a nice result for SATA drive, but the gap between M.2 drives widens because they both did it in 3 minutes and 5 seconds, which is 39% faster. The temperature of the drive has risen by 19 degrees Celsius, which is significantly higher difference than 10 degrees Celsius for M.2 drives. It probably has to do a lot with the amount of time drive was under heavy load. Let's take a look at the read speed tests. The same files which are written to the drive in previous tests will be now read from it. The first in line is 9.2 GB single file read speed test. This test will run in real time. The speed was consistent throughout the whole test, hanging close to 500 megabytes per second, which allowed the files to be transferred in 18 seconds, which is a nice result for SATA drive. However, both M.2 NVMe drives were able to finish the same task within 10 seconds, which made them 45% faster. The temperature of the drive has risen by 6 degrees Celsius. Now let's have a look at 20 GB uncompressed single file read speed test. The speed achieved during this test was very similar to the previous one. It was sitting at 500 megabytes per second, which allowed the 20 GB file to be transferred in 38 seconds. Unsurprisingly, both M.2 drives were able to do the same task 43% faster in 22 seconds. The temperature of the drive has risen by 8 degrees Celsius. Let's move to the multi-file read speed test consisting of 8,000 small compressed files which take 10 GB of space. Compared to the write operations, reading is always faster. The file transfer took just 33 seconds, which is 11 seconds slower than both M.2 boxes. The average transfer speed was 290 megabytes per second, and the temperature has risen by 6 degrees Celsius. The last test for i-tec is the 100 GB read speed test. The average transfer speed was 494 megabytes per second, with no significant drops in performance. The final time of 3 minutes and 31 seconds for copying 100 GB is a very good result for SATA SSD box and shows that if you give SATA drives enough bandwidth, which USB 3.1 Gen 2 bus offers, they can perform very well when put into external cases. The temperature of the drive has risen by 12 degrees Celsius during the duration of the test. This time, the destination drive, MP600, had no problems coping with writing the data fast enough, so there was nothing limiting the drive's performance. Compared to Axagon, which was able to complete the same task in 2 minutes and 24 seconds, and was therefore 32% faster, while being limited by the write capabilities of the destination drive, this result doesn't look that impressive. But take into consideration that SATA bus was used here at its limits. Overall, this case performed very well. The time to start moving from SATA to NVMe is definitely here. SATA won't be able to provide any more performance in the future. M.2 NVMe drives offer better performance in a smaller package. The reason to stay with SATA drives might be the price. That means if you're able to get a good deal, and also the lower power consumption that might be beneficial if you're using them in combination with the laptop. Another use case that comes up in my mind is if you upgraded your PC with an M.2 NVMe drive and you have SATA SSD lying around, so that might be a good fit for SATA External Box. What I haven't mentioned yet is that I tested both M.2 NVMe boxes with Gen 4 drive, this Corsair MP600, and it worked without any issues. The performance wasn't any better compared to using a Gen 3 drive. I just wanted to know whether it works. During the test I mentioned that M.2 drives perform in real-life copy test below the expectation set by the information provided by their manufacturers. I asked Axagon's technical support and was told that the advertised number displayed on the box was determined by running CrystalDiskMark and not a real-life use case scenario. I told them about my test because I was puzzled by not being able to reach the advertised speed, so I asked what I could do to make it run faster. They replied that the controller chips on the PCB of these M.2 NVMe boxes are not yet able to achieve the advertised speeds in real life, only in synthetic benchmarks, and that it might take another year or two before these improved versions of chips come out and will be able to achieve them. Because I also tested the ICYBOX and was able to achieve the same speeds as with Axagon, I decided to take their word for it. But I'm still curious, so if you have an experience using different external box with different controller chip, please let me know about your results in the discussion below this video. I'm definitely interested. I also found out that if I ran these tests connected to this USB 3.2 Gen 2 X2 card, which is connected to PCI Express, I'm able to achieve results which are on average 30 to 40 megabytes per second faster. So the combination of chip on the PCB of the M.2 NVMe box and the controller chip on the motherboard matters. Some combinations may work better than others. As you saw in the temperature chart, M.2 drives run much hotter than SATA drives. After reaching 50 degrees Celsius, they are uncomfortable to touch or hold while in operation, and that's normal. I recommend you wait a minute before you pick them up after you've disconnected them from your PC. So which drive should you put inside them? Probably not the ones that I used, because they are a little bit overkill. I wanted to test the maximum performance these M.2 NVMe boxes are able to achieve. There is one exception, and that is if you need exceptional endurance, because these premium drives, in case of MP600, have 1800 terabyte write durability, and this Samsung 970 Pro drive has 600 terabyte write durability. So this might be beneficial for someone who's moving a lot of data very often. Otherwise, I would pick ATTO SX 8200 Pro or Samsung 970 Evo or a Corsair MP510 drive. They are more budget friendly. When it comes to SATA drives, I would probably pick one of these two. I have very good experience with them. They are reliable and are fast. If you need more endurance, I would pick 860 Evo. This one has 1200 terabyte write endurance. This is a 2 terabyte version, and this 2 terabyte version of Crucial MX500 has 600 terabyte writes, but it's also cheaper. So if you're not moving that much data, this might be a better option, and depends what durability you need. Of course, you don't need to pick any of the drives that I showed you here and pick whichever you like. This is just to give you an inspiration. The last important thing are the cables. The ones which were provided with the external boxes are very short, so if you're not connecting them to a laptop, you might need to buy a longer USB-C cable. Don't try to save money here. Buy a proper USB 3.1 or 3.2 Gen 2, that's most important, Gen 2 certified cable, or you'll be sorely disappointed. Only quality cables are able to provide the speeds you saw in this video. Besides the original cables, which were enclosed with the USB-C boxes, I also tested a bunch of other cables. I also tested premium cord USB-C 3.1 Gen 2 cable, which is 1 meter long, and an extension which is also 1 meter long from the same company, but unfortunately they didn't work. Then I tried Thunderbolt 3 cable, 0.8 meters long, which worked fine. The speed was exactly the same as with the original cables, so if you have a Thunderbolt cable, you may use it as well. I think I have covered everything I wanted in this video, so thank you for watching and see you in the next one.